This is my last video I'm doing on right triangle trig application problems, but this is a very important one because in this video we discuss what we mean when we say the bearing of a line, okay? And so oftentimes in navigation we talk about the bearing of a line. This is different from the heading of a line, but we say the bearing of a line. But it's a type of measure we use to indicate what direction something is going in. So we usually refer to like north, south, east, and west. And so take a look up here in the top left corner. We say the definition of the bearing of a line is as follows. We say the bearing of a line, L, okay, is the acute angle. And this is very important. It's always acute, this angle here. The acute angle formed by the north-south line and the line itself. So like, for example, I'm heading in this direction. This is the way I'm going. But we say it is the acute angle that the direction I'm heading in makes with our north-south line. So always with the north-south line, it'd be this angle here. Okay, and so like I could, get rid of this stuff here, clean it up a little bit. What if I was heading in a different direction? I say, heading here, I want to find my bearing. So we'd say draw on the north-south line where it meets our line, in particular, the direction we're heading in, that acute angle right here, that is the bearing of this line, okay? So we know what the bearing of a line is. It is the acute angle formed by the line or direction we're heading in and the north-south line, okay? We just need to learn how to classify them now. So you'll notice the second sentence I wrote here, it says, the notation used to designate the bearing of a line begins with either north or south, okay, so N or S for either of those, followed by the number of degrees in the angle and ends with east or west. So really, what we're going to do is we're always going to start either up north or down south. So again, let's say I want to head in this direction right here. How might I describe it? What I would do is I'd tell my audience, start up north and then deviate this many degrees towards either the east, or we could have deviated west. If we were heading this direction, we say start up north, head this many degrees in a westward direction, okay? Because remember, west, east, okay, the ordinal directions. So I think the best way to do this is take a look at a few in this diagram that I already have kind of copied and pasted over here, but we say here are a few examples of bearings that have been graphed already. And so in terms of writing them, you notice where my mouse is here. We say the bearing of B from A is north 40 degrees east. Okay, so let's talk about a few things first. We said it's of B from A. So it's, another way to look at this is from A to B, okay? How would you get from A to B? What direction would you have to head in? And then the second thing is this. We say, really, north 40 degrees east is just telling my audience, start up north, and deviate 40 degrees to the east, okay? So if you were to start north and go 40 degrees east, this is not the same thing as like an angle in standard position, but that would be the bearing from A to get to B, and you'll notice that my vector here is pointing towards B. Okay, so a few more examples, say, hey, this would be something where I'm starting up north again. We say north 65 degrees west, but this is the bearing of B from A. Okay, so from A to B, you'd start north and deviate 65 degrees west. And so a couple of southwards also, we say, south 70 degrees east, that just means start down here at south, go 70 degrees towards the east marker, okay? There's the bearing of B from A. And last but not least, if we went south towards the west, we'd say south 20 degrees west, okay? So that'd be start south, go 20 degrees, and do it in a western deviation. That is the direction of whatever it is we're describing as heading in. Okay, so to use this notation, let's go ahead and take a look at an example that we'll work through here using right triangles. But it says San Luis Obispo, California is 12 miles due north of Grover Beach. Okay, so you'll notice I already have a diagram over here. We say San Luis Obispo, we'll use SLO, is 12 miles north of Grover Beach. So here's our Grover Beach, it's directly north, and we say 12 miles. Okay. And we say if Arroyo Grande is 4.6 miles due east of Grover Beach. So we say, okay, so 4.6 miles east of Grover Beach, and Grover Beach was down here. You land in Arroyo Grande. So the question here is this. What is the bearing of San Luis Obispo from Arroyo Grande? So if Arroyo Grande is here, and we say San Luis Obispo is up here, we'd say, okay, I want the bearing from AG up to SLO. So it looks like we're going to have to go from AG to SLO. We're going to have to start north and deviate so many degrees towards the west. So when we get an answer here, we say north, this many degrees west. This is going to be our answer here. We just need to know how many degrees to deviate. But the important thing here is forming the right triangle in the first place, which is kind of difficult for some people to see. But what I want you to understand is this. In this image, this line here that is perpendicular to the x-axis, it is parallel to our north-south line because it is also perpendicular to our x-axis, which was west-east. And when they say the bearing, we really mean north this many degrees towards the west to get to this ray right here. But what I want us to recognize is this. These two north-south lines, they are parallel. And recall that alternate interior angles, cut by a transversal and two parallels, these two angles have to be the same thing. So in other words, to find this top angle on my triangle is simply to find the bearing that we need right here. And that's probably the hardest part of this problem. Other than that, though, we can go ahead and start setting up trig ratios. What I see is this. We have a triangle. It looks like this. Always good to draw it off to the side, where the base is 4.6 in length, 4.6 in length, and 12 units in height. And the units are miles. And we want this top angle here. We're going to call it theta. So this angle theta, if I want to find it, this thing I don't know, I'm going to have to relate it to many things I do know. And so it seems to me that since I have the two legs of the triangle, the one trig function we're always using to relate the two legs as the opposite over adjacent is the tangent of this angle. So we're going to say the tangent of angle theta is the same thing as 4.6 over 12, or opposite side over adjacent side. And so since we have this, let's go ahead and just bust a calculator out here. I mean, we could say tangent of theta is approximately equal to some decimal. It looks a little bit of a third here. I've got my calculator, but we'll pull it up here so we can see. 4.6 divided by 12. We get about 0.3833 repeating. So we'd say, okay, going back over here, 0.3833 repeating. So now we need to solve this equation, solve it. And our method for doing so, of course, is to take the tangent inverse of both sides. What undoes a tangent is tangent inverse, so a tangent -1. We have to do this both sides. Of course, it's an equation. But we say this tangent inverse cancels out with our tangent. We're left with just theta. And theta is approximately equal to tangent inverse of 0.3833. Or if we wanted an exactly equal answer, we could plug in all of those threes repeating. Okay, but in this case, we'll just go ahead and go with a decimal. But 0.3833 repeating, get our calculator back out here. So I'll lose accuracy here, but 0.3833, we'll go with the approximation. So you notice I have tangent inverse. We'll click this in. We say about 20 points. Now, I notice that our original side lengths go out to the nearest tenth. And that's great. We usually want to go one extra place value than if we were solving for sides. However, I'm solving for an angle, so we could probably just say nearest tenth of an angle. And so we say 20.97. Well, that would round my 9 up to a 10. So instead of 20.97, which this rounds up to a 10, it'll become 21. We'll carry that whole over here, 21.0. So we'd say theta is approximately 21.0. We do want to write that 0 since we did round to it. Degrees. So now this does not answer the question. Remember, we wanted the bearing from Arroyo Grande to San Luis Obispo. So we found the angle, and if I insert this back up here now, then we're good. We say 21.0 degrees. However, the question was, what is the bearing? This means that we need to designate it. Remember, we had this over here. We said we'd go north and then deviate the number of degrees we found, 21 degrees towards the west. Okay, so a very good example of how to use north-south lines to cut with a transversal and have alternate interiors, but also how to read and draw in a bearing. You want to know how to sketch a bearing.